Got it. Hello, it's me, your teacher. Today I'm going to be talking about how we can use our balanced equations, which we've all learned how to do now, to calculate important things about unknown solutions or unknown masses. So the whole point of this entire internal is to have a thing that you know lots about, so like your standard solution that we've made in class, and use that sort of known information that we have to calculate information about something else, like a mystery solution, something that you're given and asked to calculate things about. So first things first, what are those big numbers? So balancing equations requires the number of each type of atom on each side of the reaction to be equal, i.e. this reaction is currently unbalanced. You have two sodiums on one side but only one on the other, and one hydrogen on one side and two on the other. So currently it's not balanced because we need them to be the same. In order to balance them, we have to add big numbers in front of the compounds because we cannot change any of those little numbers. We have to only add a big number. So we have 1 sodium carbonate, 2 hydrogen chlorides, 2 sodium chlorides, 1 water, and 1 carbon dioxide. So we consider those big numbers to be moles. So instead of reading it the way I just did, we can read it instead that we have 1 mole of sodium carbonate reacting with 2 moles of hydrochloric acid to produce 2 moles of sodium chloride, 1 mole of water, and 1 mole of carbon dioxide. So if there's no number in front of the species, so no number in front of the compound or element, then we just assume we have one of them. If we didn't only have one, if we had none, it wouldn't even be in the reaction. So if there's no number, that means we have one of those. If there is a number, then that's how many we have. Why is this important? So our balanced equation tells us what ratio of reactants we must have in order to produce the required amounts of products. So basically, it's an efficiency thing. If I don't have the right ratio, then I'm going to have some leftover stuff, or I'm not going to make as much as I wanted to. So for example, if we start with 3 moles of sodium carbonate, how many moles of hydrochloric acid will be needed to react in the same ratio? So currently in my balanced equation, I have 1 sodium carbonate needs to react with 2 moles of hydrogen chloride or hydrochloric acid. If I had 3 moles of sodium carbonate, how many moles of hydrochloric acid would I need in order for my ratio to remain the same? So again, we must keep that the same. 1 mole of sodium carbonate requires 2 moles of hydrochloric acid. How much will 3 moles need? So we should have, because 1 mole requires 2 moles of hydrochloric acid, 3 moles of sodium carbonate will need twice as much, so 6 moles of hydrochloric acid. So the ratio remains the same, 1 mole to 2 mole, 3 mole to 6 mole. We need twice as much hydrochloric acid to react with our 1 mole of sodium carbonate. And the rest of the ratio also updates, so if I have this much sodium carbonate, I will make, again, 3 times as much of everything else.